Hello everyone, welcome back to my YouTube channel. This is Neha SD, currently pursuing BE in Sri Venkateshwara College of Engineering from the Department of Computer Science from 3rd semester Bhaskara section. And today's course name is Operating System and the course code is BCS 303. So today's topic is on the principles of protection which are used in operating systems. So, introduction to the protection principles. Protection in operating systems is essential to ensure the integrity and the security of the data. It involves mechanisms that prevent unauthorized access and modifications of resources. Understanding these principles helps in designing robust and secure systems. The protection principles are sectional core principles. It consists collection limitation, purpose specification, use limitation, data quality, access and correction, and accountability. Let's look into the objectives of the protection. The primary objective is to safeguard the system resources from unauthorized access. Protection mechanisms aim to maintain privacy and integrity of the user's data. They also help in ensuring the availability of services and resources. Types of protection mechanisms. There are various types of protection mechanisms, including access controls and encryption. These mechanisms can be implemented at the different levels, such as hardware and software. Each mechanism serves to reinforce the overall security posture of the system. It is subdivided into three types, that is mechanism, description, and the examples of the protection mechanisms. Repression. Unconscious suppression of unwanted thoughts or information from consciousness. After being mugged, a person is unable to recall the experience. This is the example of repression. Denial. Ignoring or refusing the acknowledgement unacceptable realities. Planning a vacation in a year after receiving the terminal diagnosis is an example for denial. Projection. Attributing one's own feelings through thoughts, behaviors, or motives to others. This is a description of the mechanism projection. The example for this is a partner who had an affair in convinced their partner is cheating. Next mechanism is the displacement, redirecting feelings to a safer substitute object. For example for that is when placed to sit in a timeout, a child kicks and knocks over the chair. Access control list. It is also ACLs. ACLs specify which users or system processes can access particular resources. They provide a straightforward method of defining permissions for various operations. Properly configured ACLs can significantly enhance the system security. The access system list works first on the user and then it goes to the administrator and to the last it travels to FTP server. Next is the capability-based security. Capability-based security uses tokens to grant access to resources. Each capability specifies the actions that can be performed on the resource. This model provides fine-grained access control and can prevent unauthorized usage. User authentication. User authentication is vital for verifying the identity of the users attempting to access the system. Common methods include passwords, biometrics, and two-factor authentication. Strong authentication practices reduce the risk of unauthorized access. Encryption. Encryption transforms data into a format that is unreadable without a description key. It is a critical component for protecting data at the rest and it is transit. Proper encryption methods help maintain confidently and integrity of the sensitive information. Asymmetric encryption. The first, it starts with a different key. It is divided into two types. It is public key and the secret key. The public key is defined as encryption and secret key is named as ascription. It is this public key refers to plain text. Isolation. Isolation ensures that processes do not interfere with one's operation. It is achieved through mechanisms like process separation and virtual memory. Effective isolation protects system stability and security for malicious processes. Least privilege principle. The principle of least privilege dictates that users should have only the permissions necessary to perform their tasks. This minimizes potential damage from errors or malicious actions. Implementing least privilege requires regular audits and updates of the user permissions. Audit and monitoring. Regular auditing and monitoring are crucial for maintaining system security. They help detect unauthorized access or anomalies in the system behavior. Effective monitoring allows for timely responses to potential security incidents. Security policies. Security policies defines the rules and the guidelines for protecting system resources. They serve as a framework for implementing the protection mechanisms. Consistent enforcement of the security policies is vital for effective protection. System calls and protection. System calls are the primary interference for user programs to request services from the operating systems. They must be designed to ensure that requests are validated and unauthorized. Proper handling of the system calls is crucial to prevent security vulnerabilities. Malware protection. Operating system must include mechanisms to detect and mitigate malwares. This includes antivirus tools, behavior monitoring, and the regular updates. Effective malware protection is essential for maintaining system integrity. Next is the security in virtualization. Virtualization introduces unique security challenges and opportunities for protection. Hypervisors must enforce isolation between virtual machines to prevent cross-VM attacks. Proper configuration of the virtual environments enhances overall security of the virtualization. Threat modeling. Threat modeling identifies the potential security threats and vulnerabilities in a system. It involves analyzing assets and determining the potential attacks vectors. This proactive approach help in designing more and secure systems. Secure software development. Secure software development practices are essential to minimize vulnerabilities. This includes implementing secure coding and standards and regular code reviews. Training developers on security awareness contributes to more robust applications. Incident response. An effective incident response plan is vital for addressing security breaches. It should outline roles, responsibilities, and procedures during an incident. Regular testing and updates to the incident response plan enhances preparedness. The incident responses are: incident triage is the first step, deployment is the second, mitigation is the third step, remediation is the fourth, and the incident review is the fifth step in the incident response. Backup and recovery. What is backup? It is nothing but a data backup, a copy or archive of your important information on a device. So, how to back up your data device? First, you'll need to create a copy of your important information. Store data in the secure separate locations. So, regular backups are crucial for data protection and recovery from incidents. A well-defined recovery plan ensures quick restoration of services after a breach. Testing backup and recovery procedures is essential to ensure effectiveness. Future trends in protection. Emerging technologies such as artificial intelligence are shaping security practices. The focus is shifting towards adaptive security measures that respond to threats in real time. Continuous evolution of the protection principles is necessary to combat new challenges. AI and machine learning trends in the future trends are generative AI, overlap of AI and IoT, augmented intelligence, transparencies, composite AI, algorithm declaration, no-code tools, cognitive analytics, virtual attendance, wearable devices, data security and regulations, natural language progressing. Conclusion. The principles of protecting in operating systems are essential for safeguard resources. Implementing robust protection mechanisms help mitigate security risks. Continuous evaluation and the adoption of these principles are necessary for effective security. Six principles of safeguarding are empowerment, prevention, proportionality, protection, partnership, etc. Thank you.